But can you hear? Come on.
A few months ago, the Nobel Prize in Physics was awarded to two teams of astronomers for a discovery that has been hailed as one of the most important astronomical observations ever. And today, after briefly describing what they found, I'm going to tell you about a highly controversial framework for explaining their discovery. Namely, the
Georgie, what about the sound?
I can hear.
Nice. Okay. And so, two astronomers, they discovered something and they became a Nobel Prize winner, right? Winners.
Yeah.
Okay, please listen.
possibility that way beyond the Earth, the Milky Way, and other distant galaxies, we may find that our universe is not the only universe, but is instead part of a vast complex of universes that we call the multiverse. Now,
Georgie, what is a multiverse? What is all this noise about?
Well, the complex of many universes.
Thank you. At our classes, we talked a lot about this stuff. Personally, do you believe in that kind of story?
Yes?
Me too. But so far, no strict evidences, right?
Well, because there can't be any strict evidence.
Good answer. Why?
Because how do you even check? Send something outside the universe?
Good idea. Good idea. But Georgie, look, usually in science we don't have direct evidence every time. For example, Newton, when he invented gravity, did he have any strict results, scientific results of the gravity that day?
No.
No? True? When his theory of gravitation was applied to space, did we have any strict evidence that the theory of his gravity worked in space?
Well, no.
No. No. Okay, and again I would like to ask you a question about black holes. When were the first ideas of a possibility of black holes? How many years ago? A century ago, 2 centuries, 50 years ago?
Well, I think around 60 or 70 years ago.
Good job. But actually, a lot earlier. A lot earlier. Probably you are talking about strict theory with mathematics and all that stuff, and probably people got a prize, Nobel Prize for that black hole. But some people felt that there is some kind of black holes in the sky much earlier. Do you agree with me?
Yes.
Good. And even now, when we cannot see real black holes with most powerful telescope, we still believe that there are a lot of black holes, just not away from our planet. Why?
Could you please repeat?
With strongest telescope we have now, we cannot see a real black hole nowadays, even nowadays.
Well, because it is invisible.
Thank you. But we 100% sure that there are a lot of black holes. Which way?
Well, first of all, because we actually have a photo of one. The one which was taken in 19, I think.
You mean a real black hole?
Yes, don't you know it was like everywhere?
Huh. Giorgio, thank you. But it contradicts to a theory?
Well, it was possible to see it because it was shot at the moment of it consuming the matter, so it had like a light outline around it.
Ah, thank you, Georgie. Great explanation. That's exactly what I want to talk about. So we consider about existence of black holes because we have not direct but indirect consequences, right? Indirect consequences.
Yes?
And mostly when scientists try to discover something, do they have direct or indirect?
Oh, well, usually indirect.
Good. Usually indirect. And when we are talking about multiverse, probably we have some indirect evidence. What do you think? Or possibly no.
Well, I don't know.
Me too. Don't know too. So let's listen to him more.
The idea of a multiverse is a strange one. I mean, most of us were raised to believe that the word universe means everything. And I say most of us with forethought, as my 4-year-old daughter has heard me speak of these ideas since she was born. And last year, I was holding her and I said, "Sophia, I love you more than anything in the universe." And she turned to me and said, "Daddy, universe or multiverse?" But barring such an anomalous upbringing, it is strange to imagine other realms separate from ours, most with fundamentally different features, that would rightly be called universes of their own. And yet, speculative though the idea surely is, I aim to convince you that there's reason for taking it seriously, as it just might be right. I'm going to tell the story of the multiverse in 3 parts. In part 1, I'm going to describe those Nobel Prize-winning results and highlight a profound mystery which those results revealed. In part 2, I'll offer a solution to that mystery. It's based on an approach called string theory, and that's where the idea of the multiverse will come into the story. Finally, in part 3, I'm going to describe a cosmological theory called inflation, which will pull all the pieces of the story together. Okay, part 1.
Georgie, how many parts are there in his discussion?
3.
Thank you. He talks quickly and uses special terms, but can you say something about part 1, part 2, and part 3?
Well, the first one will be general part, the second will be about string theory, and the third one will be about some cosmological theory. I don't remember the name.
Oh, good. Very nice. Very nice. Very nice. And so part 1, we are talking about discovery of these 2 men who became, as if am I right, Nobel Prizes.
Starts back in 1929 when the great astronomer Edwin Hubble realized that the distant galaxies were all rushing away from us, establishing that space itself is stretching, it's expanding. Now, this was revolutionary. The prevailing wisdom was that on the largest of scales, the universe was static. But even though...
Georgie, I'm sorry. He's talking about Hubble, a very, very, very famous astronomer. What did he discover?
Well, that universe is stretching.
Thank you. Actually expanding. Georgie, look how strange all these things are. Let's say only maybe 400 times, I'm talking about, by the way, medieval times, people think that the center of everything is what?
Well, the Earth?
Thank you. Georgie, it's so funny. Only 400 or maybe 500 years ago, Earth is the center. How did the picture change after that? Give me your ideas.
Well, you name it.
I name it, but I want to listen to you, my friend. Tell me something about Copernicus and Galileo. You
Well,
know.
the general development of science and technology, like telescopes and other stuff.
Okay, but
Also some, well, tolerance to new ideas, maybe.
oh yes, but Galileo he refused to say that again. But he said what? First time in human history.
That Earth isn't the center, I think.
Good. And what star is the center of everything?
I think he said sun.
Thank you. But you said it's probably wrong. But Chronicles said that to the exquisition he said, I refuse from my words because Bible says that the earth is the center, and so okay, but after him we know that star is the center, sun is the center. What happens then?
Well, probably they declared that even sun isn't the center.
Great idea. We have a sun. The sun is a solar system, and there are a lot of other solar systems, right?
Yes?
But still it's not the end of the story. Solar systems come together, and it is what?
Well, the universe, I think.
Galaxies.
Yes.
Galaxies. And probably he will show us the picture of expanding universe, and you will see some object like a stars, but it's not a stars. It is what?
Well, galaxies.
Galaxies. And at our classes we saw the latest pictures which were made by very powerful telescopes, and it looks like you see at the sky with a lot of stars, thousands and billions of stars in the sky, but really it's not stars. It is what?
Galaxies.
It's galaxies. So crazy. It's so crazy. It's galaxies. Okay. Come on.
Oh, there was one thing that everyone was certain of. The expansion must be slowing down. That is, much as the gravitational pull of the Earth slows the ascent of an apple tossed upward, the gravitational pull of each galaxy on every other must be slowing the expansion of space. Now let's fast forward to the 1990s, when those two teams of astronomers I mentioned at the outset were inspired by this reasoning to measure the rate at which the expansion has been slowing. And they did this by painstaking observations of numerous distant galaxies, allowing them to chart how the expansion rate has changed over time. Here's the surprise. They found that the expansion is not slowing down. Instead, they found that it's speeding up, going faster and faster. That's like tossing an apple upward, and it goes up faster and faster. Now, if you saw an apple do that, you'd want to know why. What's pushing on it? Similarly, the astronomers' results are surely well deserving of the Nobel Prize, but they raised an analogous question.
Sorry, Georgie.